Great, thanks a lot, Jenny. And thanks everyone for joining. It's a little funny, I can't actually see anyone online. I can only see the slides. So I'm sort of speaking out there and hoping to connect verbally instead of visually. So as Jenny mentioned, my name's Adriana. I'm a scientist at NCAR and one of the co-chairs of the working group on water isotopes. And this working group is obviously generously supported by US CLIVAR and also NSF Paleoclimate and the Marine Geology and Geophysics program. So what I want to do today is really give you a little update on what kind of progress the working group has made over the past year, and then also tell you about some next steps that we hope to take in our third and final year. So in my mind, this working group really formed because I think there's been this momentum building. You know, over at least a couple of decades, there's been this appreciation for what water isotopes can tell us about past climate. But I think increasingly we're seeing a greater appreciation for what they can tell us about modern water cycle processes, and then also a greater appreciation for what understanding past variability in climate can really teach us about the climate sensitivity of our planet in the future moving forward. So the water isotope working group formed with these goals of trying to synthesize the kind of progress that's been made in applying water isotope information to climate problems, and then also to really start thinking about, you know, what are those next steps that this research community needs to take in terms of integrating observations and models, thinking about better data stewardship, and all toward identifying and really answering those key climate variability and climate change questions. So we decided to use both our community workshop this past year, which took place in October, and then also an AGU town hall meeting to really try to catalyze the discussion about these issues and about this plan. So we also took advantage of our workshop to try to build kind of a better network and a bigger or better, I think, more integrated community, more research community. Because if you think about the water isotope world, we really have scientists coming from a variety of disciplines, be they oceanography, atmospheric science, hydrology, ecology, paleoclimate. So I'd really like to spend most of this presentation telling you a little bit about the success of our workshop, the lessons that we learned, and also how we're going to use those lessons to move towards our next steps. And one of the things that for me was really one of the most exciting parts about this workshop were some of the surprises that came from it. When we put this together or started planning this last summer, we were anticipating about 50 participants in this workshop. And instead, we had about 115 participants from a variety of disciplines. If you look at the breakdown of the registration or the registered participants and where they came from, one of the really neat things that you see in this pie chart over in the top of the screen is that about half of the participants were early career scientists. Also, we did a lot of the workshop in a way that we could facilitate having virtual talks and virtual poster presentations. All of the discussions, whether they were the large group discussions or the small group breakouts, were done in a way to include remote participation. And so as a result, I think we had a lot of participation from many places around the world, which are highlighted in the blue shaded areas of the map. Now, the talks of our presentations were focused around 4 major areas. Those were the global water cycle, air-sea interactions, air-land interactions, and then also atmospheric processes. But what was really interesting to me is that a lot of the kind of themes that emerged from the workshop were cross-disciplinary. And so I'd like to walk you through a couple of the big themes that emerged from our workshop presentations and workshop discussions. The first theme that emerged was basically telling the story of the significant progress or the success that's been made in developing the types of observational modeling and data science tools that we need to better integrate water isotopes into key climate questions. So here are a few examples from the observation side. And as you can see from some of these illustrations, some of the things we've really benefited from are now we have multi-decadal records of isotopes in water vapor from satellites. And those are allowing us to have this global view, as you can see from the map on the bottom, of water vapor and water cycle processes. In addition to the remote sensing realm, we've seen really big improvements in situ measurement technologies, which is highlighted by the photo from the airplane. So these much more fast response and also high precision instruments are allowing us to get vertically resolved delta D and delta O18 in the atmosphere, which is really critical both for answering key climate questions, but also for evaluating climate models. And then we've also seen an investment and deployment of these measurement techniques or measurement observing systems in formalized networks like the National Ecological Observatory Network. On the modeling side, we've seen a lot of IPCC class general circulation models begin to include isotopic tracers in their current model versions. And we've also seen the development of some really exciting tools like water tagging, which is shown here. One thing I want to point out, which I didn't on the last slide, but keep in mind that I'm going to show a few pictures here from the various talks and also posters that took place at our workshop in October. And every time I do that, to make sure I'm giving people the right credit, I've written their name presented by so-and-so 2019. So these are a couple of figures from Jun Hu. And in his talk, what he was showing is that you can essentially tag the places where moisture has evaporated from the ocean or land surface, and then use that type of information to understand how moisture source regions are changing and how those shifts in source regions are then affecting signals of isotopes in precipitation, and ultimately, for his interest, in the isotopic record that's recorded in cave speleothems in Asia. Now, we've also, in addition to seeing more isotopic tracers in GCMs, we're seeing the addition of these tracers in regional models, weather forecasting models, cloud resolving models, and also large eddy simulations. And finally, I want to talk a little bit about some of the major advances that we've seen on the data science side. And here, what I wanted to highlight was an example from Greg Hakam and colleagues, where what we're seeing is this push to take proxy information through a data assimilation framework and try to build better, more accurate reconstructions of our climate of the past temperature. So in this case, what this schematic is trying to illustrate is that we can use climate model information to predict what's going on in the environment, take those environmental conditions and use them as input to our proxy system models, which are then basically forecasting what isotopic signal you would see in something like trees or corals or ice cores based on the environmental conditions. And then we can directly compare the output from these proxy system models to observations in the same units. And then finally, learn something from the difference and use that to update our climate predictions. So these types of frameworks have become really, I think, powerful. And part of that power comes from this integrated way of using models and observations. Okay, moving on to the second theme. Here, what we saw was really that isotopes give us this way of viewing the very interconnected nature of the various components of the Earth system. And to illustrate that, I've grabbed this figure from Alexander Thompson's presentation from our workshop. And in this, what he's showing us is the difference in the isotope signal and precipitation between a vegetated Sahara of the mid-Holocene and then a desert Sahara of the present day. And the key point that he tried to emphasize was that you can't get this sort of isotopic signal, this very large signal, if you're not accounting for the vegetation changes. So it was a way of highlighting the important role that the land and atmosphere exchange can play in shaping atmospheric hydrology and shaping climate. The third theme was really about the widespread use of isotope ratios as tracers of climate dynamics or moisture transport. And this came up in a variety of examples. Some had to do with how do we evaluate changes in moisture residence time in a warmer world, or how do we see and evaluate changes in moisture transport that affect the dependencies of our precipitation on remote source contributions. Other examples where we saw this talked about were, for example, looking at shifts in the ITCZ, or thinking about modes of climate variability, as shown here for ENSO. So these are actually a couple of figures from my own work. And what they're showing is basically the signal of the large-scale moisture flux divergence shift that you get between La Nina and El Nino. And you see that reflected in a very tight correlation in the delta D of the free troposphere that's simulated in CAM. The fourth and final theme had to do with this notion of isotope ratios providing us a much more coherent or integrated signal of precipitation variability. And so when we think about what the world is going to look like as it warms, one of the things we worry about is that the precipitation cycle might intensify. And yet we have a very hard way of actually detecting precipitation changes given traditional measurement techniques. A large reason for that is that precipitation fields are just very variable in both space and time. So one of the ways we talked about using water isotope ratios is to give us a more integrated picture of those precipitation changes. And to illustrate why this should work, I've given you these two figures from a paper by Jess Merman and also my co-chair colleague, Kim Cobb. And in this study, what they did was they compared the precipitation amount, which was collected at this location, Mulu, with precipitation over the region that's recorded by the TRIM satellite. And that's what's shown on the left side panel. And what you can see in this panel is that there's essentially no signal. In other words, the precipitation you collect locally isn't telling you much about precipitation in the region. On the other hand, the right panel is showing the correlation between TRIM with the isotope ratios measured in that precipitation at Mulu. As soon as you look at the isotope ratios, you see a regional signal emerge. And so where we hope to apply isotope ratios in this problem is looking at the signal to noise or looking at the time of emergence of precipitation changes in places where precipitation variability is particularly high, or maybe precipitation is very scarce. Now, these were the four major themes that emerged from this workshop, and I think they're very nice and helpful for telling us about where some of the opportunities lie for applying water isotopic tracers. But it was also very valuable to think about the places where we still have barriers that are really preventing us from applying these tracers to climate questions. And so, as you can imagine, we talked a lot about just various observational and modeling needs. And because those were such a big part of the breakout sessions that we had, I'm going to focus on those a bit separately. But here, let me emphasize a few of the barriers that kind of surprised us. For example, you see communication highlighted. One of the things we talked about is that really the water isotope research community needs to use more plain language to talk about what it does. And we need to kind of fight the perception that we're too niche or maybe an add-on quantity. So some of the ways we talked about doing that, we're doing a better job of telling our own success stories, how isotopes are helping us answer climate problems, and also providing better tutelage and mentoring for young scientists who want to use these tracers in their own research. We also talked about communication as perhaps needing improvement among each other within the community itself. And for example, a good example of this is thinking about how do we better transfer knowledge between observationalists and modelers. And some of this now starts to touch upon the quantifying uncertainties barrier and also the data stewardship barrier. For example, we talked about the need to better communicate how we're calibrating the data we collect, why we might discount certain paleoproxies, how we describe our data when we store them, whether we provide enough information so that others know exactly how to use that data, how to download it and apply it. A very different barrier that we saw come up in the conversation was this notion of scaling up, which I've mentioned on the right-hand side. The question of scaling up is sort of an interesting one. When you think about water isotopes, the signal that you're fundamentally measuring is a molecular signal telling you something about thermodynamic properties or kinematics. And yet, when we make these molecular measurements, what we're really trying to understand are bulk fluxes of moisture, say from a forest stand into the overlying atmosphere. And then we want to take that kind of information and scale it even further up to say something about regions or global climate. So to really make that work, we need to make sure that we continue to have a strong underlying experimentally based theory for how isotopes record water phase changes so that we can best represent these processes in models. So let me turn a bit now to the observations and modeling needs, and I've really decided to frame these more in terms of recommendations. On the observation side, I think the overarching goal is stated by this first line. What we really hope for is that water isotopes can be seen and treated more as essential climate variables. And what follows underneath are really a series of efforts that I think we can bite off to try to make that happen. So the lowest hanging fruit is really making sure we're taking advantage of existing campaigns, for example, research cruisers, to make sure that we're gathering those very low cost rain and seawater samples, which all they really require are some plastic bottles and then cost on the order of about $1 to analyze. At the same time, on the atmospheric side, we want to continue to invest in measuring the height resolved delta D and delta O18 that's so valuable for evaluating climate models. And that can be paired with expanding our global coverage through remote sensing. The really good news here is that we don't necessarily need more sensors in space, since we already have sensors that can retrieve HDO. What we really need are the algorithms so that we can take those raw measurements and get the HDO information from them. One of the other points that we noted as part of the workshop is that for many users of water isotopic information, the remote sensing data still feels a little bit foreign, like it's in formats that they're not quite familiar with. So we talked about synthesizing remote sensing products and their availability, and including not just the space-based ones, but also the ground-based ones. We also talked about the need not to just take advantage of existing or future campaigns targeting individual processes, but really to invest in those networks or systematic observation systems. And of course, I already mentioned that NEON is underway in making water vapor and precipitation isotope ratio measurements across many US sites. But we talked about the need for global climate problems to really expand those networks into key places like the tropics, the poles, places where we have particularly rich paleoproxy information. And then also I've noted these emergence locations. And by that, what I'm talking about are these places where variability in something like precipitation may be particularly high, but the signal to noise in isotope ratios is much stronger. For many of these observational networks, it would be valuable not just to get the kind of easier measurements like water vapor, rain, and surface water, but also soil water to see that full system view. And then finally, we talked about leveraging citizen science more, particularly where there are these moving phenomena like hurricanes, where we could quickly gather very high spatiotemporal resolution measurements using tools as simple as plastic bags and plastic water bottles. Okay, on the modeling side, of course, I think the biggest need is making sure that isotopes are in the most up-to-date GCM versions. And sort of along those lines, but going even further to really look at some of the uncertainties about different isotope physics, we talked about the need to do a new intercomparison. It's been more than a decade since the water isotope community did a GCM intercomparison. We want to keep pushing forward those efforts to incorporate isotopes in higher resolution models so that we can also do model hierarchy experiments and really try to evaluate model physics, chemistry, and biology. And then we talked about using these tools now to advance problems like evaluating hydrological extremes in the future. We also talked about wanting more gridded products like isotopic reanalysis and continuing to support the development of proxy system models and their integration into paleo reconstruction projects through data assimilation frameworks. Okay, so as not to end on sort of a note of the large task list of things that are left to do, I wanted to at least mention a couple of success stories since our workshop, already moving towards breaking down some of these barriers and applying water isotopes. This past winter, we had a couple of very exciting international field efforts where water isotopes were really integral, being collected on a number of different platforms, and not just isotopes in, say, rain, but also seawater and water vapor. The first example here is from the big Eureka mission, and on the US side, that was the NOAA-funded atomic mission. And then the second example of that is Mosaic, which is probably best known for getting a large ship stuck in the ice over the Arctic winter to try to understand Arctic climate variability. And then looking forward, we really want to continue to be at the table for these early planning discussions about campaigns that can target climate systems. And so one of the ones we're particularly excited about at this point is thinking about an ocean and boundary layer observing system in the tropical Pacific. And here what this slide is trying to show is some of our vision for where water isotopes may enter this picture. For example, the measurements are highlighted in the black, the bold. Some of the platforms are shown by the pictures in the red. And then really the outcomes of this are shown near the bottom by where the arrows are. For example, they include things like a multi-decadal reanalysis, a better understanding of clouds and the boundary layer, greater community engagement and capacity building, and also an opportunity to evaluate the freshwater budget in the tropical ocean environment. So let me leave you then with my final slide, which is thinking about what are the more immediate next steps that this working group hopes to discuss and move forward on in the next year. And really, I think the places where we need to do the most planning and start to take the first next steps are having to do with, one, continuing the momentum from our workshop. That means continuing to tell success stories and then provide guidance to early career scientists in our community. Two, to help set priorities for observations. That includes the low-hanging fruit I mentioned, but then also being at the table for planning stages of these bigger campaign efforts like the Ocean Observing Network I mentioned in the previous slide. Three, on the model side, mobilizing that next swing, that next isotopic GCM intercomparison. Four, on the archival and data stewardship side, we can support existing efforts like the NSF-sponsored ISOBank, but then also start to think about or at least research institutionalized repositories, for example, through NOAA. And then fifth and finally, we'd like to look at guidelines for integrating with NOAA operations, both on the satellite side and then in terms of data assimilation and reanalysis. So with that, thank you so much for your attention, and I would be happy to take any questions or to open up the floor to other members of the working group.
Great, thank you, Adriana. So if you have a question, feel free to unmute yourself and ask them out loud. You can also type your question into the chat box and I'll read it for you.
Hi, Adriana. This is Caroline Clayson. Can you hear me?
Yes, I can. Thank you.
Okay, great. Every time I use a different platform, I never know if my headphones are working right. I just have a quick question for you that is related to the fact that I'm writing up a little section for the next TPOS observing system backbone section on super sites in the tropical Pacific. I've kind of been charged with writing that section. And of course, you have a little discussion in there about super sites. So my question actually for you, because we don't have much time, is would it be okay for me to just give you an email at some point and kind of see what your group was thinking at in terms of what kinds of observations and value that would have, so that we could make sure that if we're putting something in there that we get your perspective as well?
Please, that would be great. And I can already say that Kim has actually been the co-chair most involved with TPOS 2020. And she contributed quite a bit, at least to the first report. So that would be wonderful to continue that conversation.
Okay, I'll CC. I'll send it to both of you then.
Great, thank you.
Any other questions for Adriana? Do you see we have a lot of working group members on here, and we were joined by Kim as well. So we have all 3 co-chairs here.
Great, and I'm there. I think I've stopped presenting or showing there.
Yeah,
I can finally see people. It's nice to see faces.
We also might still have some of our program managers here too. And since they don't necessarily have a regular interaction with the working groups, I do want to encourage you to ask any questions that you might have of Adriana and the other members of the group. Not to put you on the spot.
Well, this is Candace. Maybe I just thank Adriana for a really interesting presentation and update on what you guys are doing. And yeah, I actually will have to chew on this a little bit to think about some of the themes and recommendations that you guys have come up with. But I would say that the MG&G program is certainly open to following up on some of these things through proposals to the programs and just in conversation. So I should say that the 2 program directors in the marine geology and geophysics side, so the paleoceanography side of this right now are Dan McCorkle and Steve Hoven, and neither one of them was able to join us today, so I will report back to them, but they would be happy to field any questions from any of you.
Thank you, that would be great.
So I will make a comment that in terms of participating at the workshop, that this is Mike Patterson, director of US CLIVAR, that this intersection between the modern and paleo community, the drawing together of the observational and modeling communities in both of those other communities, as well as targeting climate, water cycle, bringing together ocean atmosphere interaction along with land atmosphere interaction, the integrative nature of the water isotopes themselves, that they can cross over all of these different sub-communities, right, our sub-disciplines, and integrate in such an important way. I think, Adriana, the slide that you showed that really emphasized the work that Kim and her colleagues did about these signal to noises that come through using this really unique power of these data for illuminating connections that we wouldn't otherwise see is really an important message. So I just want to congratulate this group for having continued forward in this thought, even in your next year, and the messaging in the workshop report that you're drafting, the importance of this communication role and bringing these communities together. And I am hopeful that as you complete in the next year the work of the working group, that those communication efforts are really well addressed, so that the instigation and the entrainment of early career scientists to work collaboratively still, goes forward. And it's really helpful to hear from agency managers who see the importance of the investment there for collaborative work that entrains especially the next generation of scientists who are really willing to do the collaborations right from the start. I'll stop there.
Yeah, no, thanks for that, Mike. And one thing I forgot to mention entirely is that the workshop report is drafted, and once our working group has a chance to kind of go over and edit it, that'll be coming out the door pretty soon. So that'll be at least one more bit of communication material that will be out there, sort of synthesizing some of these ideas. But this notion of, making sure that we don't let the communication barrier be the one that hangs us up, I think that's a really nice point to make, because it's certainly that would be a shame if we can't sort of tackle what I think of as one of the easier problems of making sure that we're sort of there for the early career people coming into this community, and also folks who aren't necessarily entrenched in the water isotope side, but kind of have a hint for or see some value in kind of making the collaborative efforts to integrate some water isotopic information in their research. Hi, Dave.
Yep.
Are you on?
See, no, we can't hear you, Dave. Can you type your question in the chat box maybe, and I can read out loud for you. You can also, on the bottom right, you'll see the three dots. If you click on that, you should be able to play around with your settings for audio. All right, it doesn't look like we can hear you.
Well, we do want to hear from Dave. Is there a way for him to call in?
Yep.
He's going to hold up.
Let's see.
Zoom.
All right.
That's too bad.
See, Dave, if you can call in.
NCAR? I didn't see actually what's on the bottom. NCAR question mark? About, is this a question about NCAR's role perhaps in this broader effort? Yeah, so to some extent, I feel like I partly represent some of that effort or support. So I was a recent hire just a couple years ago into the research aviation facility to bring water isotopic capacities to our airborne program, realizing that this vertically resolved information is very valuable. But there's a much longer history before me, right, of isotopes in the NCAR model. And David, of course, has a long history in that regard. And it kind of continues. One of our other working group members, Jesse Nussbaumer, is also, I think of as sort of the go-to NCAR expert these days on water isotopes in much of CAM. And there are others who have been, I think, very attuned to it through the land model and the paleoclimate working group as well. So I think this is sort of a little bit my personal feeling now, maybe more than an institutional statement. But I actually think we're incredibly well poised to support the community because we have both the observational capacity, kind of the paleoclimate lens, and then also the modeling tools. And what I'm hoping is through collaborations with other agencies like we had for Eureka, Atomic, and other types of big campaigns like that, that really helps open the door and makes this more accessible for kind of the rest of the isotope or climate community who can't necessarily just get an isotope instrument or get an isotope-enabled model kind of all on their own. Did others want to jump in on that one?
He did make a comment. We are revising P2C2 this year. This group should pay attention to new themes in it.
Thank you.
Okay. So I see it's 1:35. So I think if anyone, unless anyone has any final questions, we can end here. I don't see any questions. So thank you, Adriana, for presenting and representing the Water Isotopes Working Group today. And I'll send out a recording for those who weren't able to join, and we can share that with everyone else. So thank you again.